Hi there, welcome to video number 195. This one is on mutually exclusive events. The keywords I've got for you are mutually exclusive and probability. Now, mutually exclusive events are events that cannot happen at the same time. So for example, if you've got a coin and you flip the coin, you cannot land on heads and tails at the same time. Therefore, those events are referred to as being mutually exclusive. Probability is the chance that something happens. So the method states mutually exclusive events have probabilities that sum to 1. That's the most important thing to remember, which means that the probabilities add up to 1. Find the missing probability for a specific outcome. You will need to do some adding, subtracting of decimals or fractions. Add the probabilities you have and take away from 1 to find the missing probability. Questions can be made more complicated with the introduction of algebra, which is standard in maths, that we make things a little bit more complicated sometimes, but algebra ultimately will make things easier. So question number 1, the probability of getting a head on a biased coin is 0.3. Biased meaning it favours one thing more than another, remember. So what's the probability of getting tails? If we were going to write the notation, big capital P, brackets, T for tails, E. We don't have to write that, but it's nice to know that we can. That is going to be equal to 1 minus 0.3. 1 take away the probability that it's heads. There are only two options on a coin. 1 take away 0.3 is 0.7. Most of the time, most people can work that out fairly easily. Anyway, so 0.7 is all we need to write down for the answer to that question. Okay, nice simple one. Question number 2. Reginald has a biased spinner. Means it lands on one thing more than another. The spinner is labelled with sections 1, 2, 3, 4 and 5. Probabilities described in the table below. Work out the missing probabilities. So these are mutually exclusive events. The spinner cannot spin and land on a 1 and a 2 at the same time. It can only land on one of those numbers. Therefore, they're mutually exclusive events. The probability, unfortunately, has been given to us as an expression, 5x, for landing on a number 1. Then we've got the actual probability of 0.3, or 30% chance of it landing on a 2, whatever you want to call it, but 0.3 as a decimal, 0.08x and 0.32. So we've got to, in this question, form a bit of an equation, right? If you're not sure what I'm talking about, go and watch the forming equations video in the algebra section. But 5x's and x is going to give us 6x. So there's 6x's overall. Then we add up these numbers, all right? So 0.3 plus 0.08 plus 0.32, that's going to give us 0.7. Okay, all of that sums to 1. It all adds up to one whole amount. Okay, now I've just frozen this. I'll just pause for a second whilst I come back into the real world of recording. There I am back now. I'm going to take away the 0.7 from the 1. That leaves me with 0.3. And 6x is left on this side of the equation. We're now solving this equation by dividing both sides by 6, sorry, not by 3. And because that's the number that's in front of the x. If we do that, we get 0.3 divided by 6 gives us 0.05. All right, you can check that on a calculator, but if you're doing it in your head, you can do 30 divided by 6 and then divide your answer by 100. Okay. Now x, that's the probability of getting a 4, and again I'll use the notation, probability of getting a 4 is equal to 0.05. We found that. What we need to do is multiply by 5, because x needs to be multiplied by 5 to find the probability of getting a 1. So probability of getting a 1 would be 0.25, because 0.05 times 5 is like doing 5 times by 5, which is 25, but then dividing by 100. Okay, so it's quite a tricky little question. But forming the equation and solving it actually makes it a bit easier, hopefully, to understand. Okay, now, question 3. We have got some blue, red and yellow counters that have been put in a bucket, and there are 3 times as many yellow than blue. There are 5 times as many red than yellow. Work out the probability of picking a red counter from the bucket. Tricky little question this, because there seems to be no numbers, apart from how many times more there is of one counter than another. So if we took the blue to be x number of counters, again it's an algebra thing, blue is going to be x number of counters, some number that we don't know. Then we're going to write an expression for the yellow counters, because the information we've got there says there's 3 times as many. So 3 lots of x is 3 times x, which is written as 3x. And then there are 5 times as many red than yellow. So the red expression is going to be 5 times this, 5 times 3x. 5 times 3x is 15x, right? So what we've got is an expression for all these things. Work out the probability of picking a red one. So it's going to be 15x out of something. Okay, now the total is all of these expressions added up, because that's the number of the only counters that are in there. These events are mutually exclusive. You can't get a blue, a red and yellow at the same time. Adding all of those up gives us the total expression for the total number of counters. So that's going to be 19x. All right, sticking that on the bottom there gives us a fraction and therefore a probability. All right, that's our answer, but we can cancel the x's. So we can just say there is 15 out of 19 chance of picking a red counter from the bucket. All right, so I'm hoping that that makes some sense to you. It's a pretty tricky little last question, but in essence, again, I've frozen, so I'll just pause. In essence, these questions are really simple. You just take away something from one and you've found the probability of the other thing happening, right? If there's only two events that are going on, right? You might need to add up and take away, but ultimately it's a bit of adding and taking away of decimals, fractions. All right, thanks very much for watching. Hope you're all well and doing fine, and you will see me whenever you watch another video. Cheers, bye.